Okay, next we have network security, and this kind of boils around defending the perimeter, right? Defending the perimeters of our network. So with network security, we want to take a look at a few things. MAC limiting and filtering, okay? We'll talk about what that means. We want to look at 802.1x. We want to look at disabling unused interfaces and unused application service ports. Much like we talked about unneeded services on a server, we want to do the same thing on our network devices. And then also covering rogue machine detection. So how do we know, or what should we do about machines that are not authorized to be on our network pop up onto our network? All right, so MAC limiting and filtering. So as we know, a MAC address is a media access control address. So the MAC address, it's a 48-bit hexadecimal number, and that number is hard-coded onto the NIC or the network interface card, whether it's wired or wireless. All right, so those things are virtualized in virtual environments. Cisco UCS chassis and so forth, those MAC numbers can be spoofed, so to speak, or virtualized, so you can change them on the fly if necessary. But generally speaking, network interface cards, HBAs, if we're talking about on a fiber channel network, those types of things have addresses that are hard-coded onto those cards. All right, we're talking about NICs here in this instance. So that MAC address uniquely identifies that device on the network. So we have a layer 2, which is a MAC address. Then we have layer 3, which is an IP address. All right, if we're talking about the OSI model, that layer 3 translates down to a layer 2, right? An IP address resolves to a hex address, or a MAC address rather, hexadecimal. So we can basically limit what MAC addresses can obtain IP addresses, and which limit what MAC addresses can connect to certain ports on a switch. All right, so in doing so, we can do something called 802.1x. And that is otherwise known as EPOL, or Extensible Authentication Access Protocol over LAN. And with that technology, we have three components. We have a supplicant, which is the host. We have an authenticator, which is a switch. And then an authentication server, or radius server in this example, right? Remote access dial-in user services. That specific setup allows us to very granularly control who can connect to the network, who can access specific ports. So when an actual machine tries to attach to a switch, rather than just blindly giving access to that device, it will not authenticate. That actually passes the authentication job, so to speak, over to an authentication server. The authentication server will then check its credentials of the user trying to log in or the machine trying to log in and say, hey, do you have access to this? Are you allowed to connect to this port, or are you not? And if you are allowed, connection happens, and then all is good. The computer can communicate on the network. If they can't, then they're denied. And that gives the administrator very granular control over who can access the network. All right, and it gives us the ability to shut things down very quickly if need be as well.